Welcome to Rescale Models. I'm Jason, your host, and I do models and electronics and Nintendo Switches. What's up with that? Wow. What's going on, everybody? How are you doing? It is the early morning for some people here in America. It's 5:46 a.m. I'm not sure where it is in your time. If you're rewatching this as a video, this is going to be a video where I am mapping out some of the test points on a working, good known Nintendo Switch for diode readings. And normally I map this out and I write down all the readings, but I am going to try it on this stream. Hey Sarah, how you doing? I am going to try it on this stream and see if I can just watch it back and write down all the values. So if you want to come and join and chat, go right ahead. So here we go. Overhead camera. This is the known working switch number 2. So this one had the bad EMI filter that was fixed on it. So I am going to reading some test points. I have a little rig set up here with yeah, I'm doing all right. It's just, it's going to be a long day, so I wanted to get this done. So I have this little test point here, and I'm going to, touch the different spots to see the diode readings. So let me put up the, let's see here and see if I can get, yeah, see I have all the different test points, and I can get readings off of those. So let's see if I can get this hooked up. So I need the red on ground. Clip that on the USB port, and I will clip my ground lead there. So now if I come over here and I touch this point there, I get a diode reading of that. So clean that off, and let me get rid of this beeper because nobody wants to hear that. Okay, so, and the meter would be helpful for you. So I am going to start down here by the battery with some of these test points. I've already tested all the pins on the BQ chip, so I just want to hit a couple of these test points over here for the record. So that is a 0.5 diode there. Sure that's showing up. So another 0.5. So I'm hoping I can watch this back as a reference and get all these values and put them in my spreadsheet. That one's open. That one is that. So, hey Andy, how's it going? Oh, hey man, I appreciate that, Andy. That's pretty cool. Yeah, I'm a big fan of Phil's channel. Yeah, and he's super helpful too. Okay, so yeah, we're just testing all these test points for a record of the diode readings. So that's extremely low, isn't it? So I just made up this little rig here so I could test these pretty easy. And then I can go back and watch the video and see what test point that I am looking at. And I'm actually going to make that bigger. There we go. That's probably better. So, because I am making a database on the computer, so I could take a minute and show you guys that. Let me see if I can pull it up. Let's see here. Yeah, I can pull up the database I have so far. And this database is posted on my Patreon page. There's no need to sign up or anything. You can just go there and download what I have so far. And it's not, doesn't cost anything. Let me just put this here. And let me go to, what is that, monitor 2? Go to monitor 2. Put that down. And, well, right here is DigiKey parts. And then here is the parts I use with all the links. And then right here would be the diode reading off the BQ chip. Diode readings off the M92 chip. Diode readings off the USB-C port. And then the P13 USB chip is what I have done so far. And then now I'm doing the different test points around the board. So that is my goal anyways. On Saturday I plan on streaming my first time with the P13 chip. I'm going to change it on air live. So that appears to, no, there's one over here. That's going to be ground. That's an odd one. That's a power rail, I believe. So I think these are all power lines. Yeah, these are going to give me a reading, but they're all power lines. Okay, so we'll come over here to the USB-C port. And there's that one. I'll do a cross like this. So we're just checking all these different points here. That one's going to be the same as that one. So that's a ground. That's a data line, I would assume. Yeah, it's going through a filter, so I'm assuming that's a data line. That's an open. It's probably not connected to anything. It's ground. And it's that. It's going to be open. Okay, I'm going to clean off my tip here. And so we have a data point here, a test point here, and 6. Actually, this is still all working. So before, when I was doing this, I was stopping to write down every measurement on a enlarged photo, and it was taking forever. So I figured I'd put it in video form and just watch it and write down my values. And as I said, this is a good working switch. Everything works on this. So we're just going to test these all here like so. I don't know how far we're going to get into the board. But, you know, if you need a reference, if you're looking at your board and you are getting a weird reading, like, you know, you don't have any shorted caps and you still have no power, and you changed your M92 chip or your P13 chip and you still have no power, you know, you can come back and, you know, check all these test points with these diode readings here and see if anything is out of the normal for you. So this is a interesting thing I came up with to do this. I basically zip tied a probe to the side of one of my gooseneck lights, and it allows me to accurately touch different points without scratching the board or, shorting things out, because I had previously shorted out an M92 chip and was not happy about it, and now I'm chasing down a nightmare of that. So I came up with this method. At my old job, I had a test bench that had a table on it that can move in the X and Y direction, and then I had a probe head that could move in the Z direction, and you could sit there and you could touch test points all day long, and it hooked up to a meter. You could even hook it up to your oscilloscope signal generator, and you could touch and test different points. And I was like, I have an XY table here, and I was wondering if I could make one, and then I needed the scope, so I came up with this quick design here to do this. So that's a high one. That's also a high one. This is probably going to be nothing. Oh, hold on a minute. Speak of the devil. So, let me see here. Hold on, I just got a message. Just tell him I'm live. Yeah, well, okay, so, alright, back to this. Sorry about that. Alright. I'm actually talking to the coder right now. It was funny. Alright, so let's see here. So, okay, we checked those. Let's check this one here. And yeah, these are all, that one's going to read what that one read, and it's open. And that is that. So that is this section of the board. So let's check these test points here. These are going to be data lines from the NAND. So I'm assuming this whole bar here is going to be ground. No, I was incorrect. That is not ground. Okay, so let's check here. Okay, these are all separate data lines with readings. Are they all going to be the same? Now, if you have one of these that are different than this, you're going to have an issue on your data lines from your NAND. And what I've discovered in my random testing and popping in a signal, if you have a data line that is, it's not going to be shorted, but it's going to be pulled to ground enough to where it doesn't read short on any caps, but it's still... Hey Phil, how's it going? Yeah, Sarah, that's funny. Yeah. Yeah, it is working. Yeah, it is working out. So, but anyways, you can have a data line, and I noticed this with the M92 chips data lines, and I'll show you those in a second here. On these M92 data lines here that go to different points in the board, like there'll be one that goes to the BQ chip, and this is separate from the clock line. The clock line's different. There's one that goes to, there's a max IC here. It goes to all the power management ICs, and it's basically a signal to say, hey, all is good at the charge port, all is good at the battery. You can go ahead and power up your section of the board and make it all good. And if you have a short, like across these capacitors or in the chip, it'll read short and it won't send that signal and nothing will power up. So you'll get a no power display. But if you have one of these data lines that is pulled to ground enough to where it's not shorted, but it doesn't meet the threshold voltage of a signal to read like a signal, it will also shut down and you won't have any shorted capacitors. So we're going to come up here. I didn't check this one here. So just check it. So I'm just basically, wow, Sarah getting crazy in my chat too. That's cool. Yeah, Phil, I'm just using that little probe setup that I showed you. Let me see. I got the little probe connected to the gooseneck thing. And hey, Jaden, how's it going? And I can just touch different points on the board, and then I'm recording this so I can play it back and get all the diode readings, because it was getting crazy trying to just read and then write it down. So I figured I'd stream it, and then I can use it as a reference. So I'm just going around all the test points with diode mode. And yes, I know I have a red probe connected to ground, people. I didn't think that through. And I wasn't about to change it. Yeah, you can have a short without showing a full short. And actually, I want to demonstrate it because it's an interesting concept that a lot of people don't see happening here. Let me go to this right here. I will give you a demonstration of what I'm talking about here. If I go to this screen, okay, so you have a data line and it sends, what? Why is this not open yet? Okay, there it goes. And that's on my, let me just get a new whiteboard, hold on. Okay, so you have a data line that sends a signal like this right here that tells everything is good on the M92 is going to send a signal that everything's good. Now, the receiving chip, whether it's a Max IC, the BQ chip, the P13 chip, whatever chip's going to receive that signal is going to have a threshold voltage that it needs to see in order for it to register that signal. And that threshold voltage is probably right there on the signal. So the signal has to send a pulse higher than your threshold voltage right here. We'll just do TH hold, your threshold voltage. But if you have a signal that is semi-pulled to ground, it doesn't have to be a full short, like so, and the threshold voltage is here, you're going to read a line that's not shorted, but it's being pulled too low to meet the threshold voltage, and then the signal is not going to be read as a signal, and then it's not going to work. So you can have a line pulled to ground, and the best way to test that is if you find the line and you test it and you compare it to a diode reading of a known good board on that line, then you'll see that if the diode mode reading doesn't match, you can have it pulled to ground. Now, you can have an issue that pulls that line to ground within a chip. You can have that issue. Wow, this is just what happened. Okay. You can have that as an issue that pulls that line to ground with a resistor that is reading not the correct value anymore. So if it's went lower in value, it could read a different value and things like that. So that's what I've discovered that with this M92 chip, where I've injected noise from the signal generator, just a 0.8 noise, and most of it was filtered out by the caps, but on one that I've changed the chips on and I still had a no power issue, it was clipping the signal, but in order to find out where it was clipping the signal, I'm going to have to pull a BGA chip, and Phil hasn't told me how to pull a BGA chip yet and put it back on a switch. Alright, have a small tolerance in different boards. Yeah, that is true, but if a line is being pulled semi to ground, it's gonna be a larger difference. It's gonna be a huge difference on diode mode rating. Also, the meter I'm using, the benchtop meter I'm using, has a higher accuracy rating, and it also I can set the voltage as what it tests at, so it's set every time. Like if you have a battery and a meter, the battery can die a little bit and the voltage can fluctuate. So this is more, it's going to be a little bit more accurate with my meter. But like I said, this is, I'm streaming this because I didn't want to sit here and talk to myself, and this is for me to make my document to send out to you guys, whoever wants it. So I am just doing this because I was literally testing one point, writing it down, testing one point, and writing it down. Yeah, you're looking for larger differences, Phil. That's what you're going to do. With the new circuits, are the values different with them being on a board? I'm not sure I know what you mean there. If the values of the components will be different on a board than they would be if they weren't on the board. But right now I am just most of these data points, like if you look here where the NAND is, most of these lines that you see coming around here with test points, they're data lines. So if you have a huge difference in value on these data lines, then you might have either a short, it's being pulled to ground, or it's not making a connection. That's why I'm doing this with the NAND connected. I'm also going to test the test points on the NAND in a little bit. So I'm going to come back up here okay, so let's get the light on that. Everybody can see that. So we're going to and some of these are redundant to test because they're all the same. So, but they're going to get tested anyways for completeness. And this way anybody can, can come access this video and, just follow along and test all the points on the board and see if they get some kind of wonky reading. So, and this switch has been fully tested by my son. I mean, fully tested. He played the stuff out of it. So, but as you can see with this little probe setup, I can touch any point with accuracy and not worry about slipping or things like that. So I hope it's coming up good on your side. There's another ground pad. So, or at least you're getting paid. So I bet you're. Yeah, I'll pull a BGA later. Yeah, if you're gonna pull a BGA, I need you to pull a max IC. Either on that CPU board you had. If you could pull the CPU max IC that I pointed out to you, and the one on the back, I'll show it to you in a minute when I flip the board over. If you could pull those two, I want to see how bad they would be to reball and put back on. Because if you actually reballed them, that wouldn't be too bad. It's not that many. You could do that by hand. Yeah, resistors will still read a different value being on the board, depending if there's a capacitor in line with them. Because if they're in series, the capacitor is going to charge from the little bit of voltage you put on the resistor, and then it's going to skew your value of your resistor. But normally, if you read a value of a resistor, it's going to be pretty close. Yeah, it's going to be pretty close. You don't have to do it with solder paste. It's probably like 15 balls. You could just do it by hand. I don't need you to find solder paste. But yeah, you can measure like a value of a resistor just on the board, and it'll give you a pretty good reading. So let's see if I can get in here to this one. I don't know if I can get in there to that one. Might be a little bit trickier. Oh, I did it. Look at that. Alright, I'm going to have to turn this board around. Make sure my clip doesn't come off. So, where am I? I'm looking way over here. Oh, this is not going. There we go. Yeah, like I was saying, I have one of these test benches at my old job, and you know, they cost about 25 grand, and can you believe they wouldn't let me borrow it permanently? It's just rude. I mean, I was like, just let me borrow it, and you know, it's all good. I mean, I was the only one that ever used it anyways. Oh, that's gonna block the camera. So let's check these points here. These are going to be the same, but I'm going to test them anyways, just for completeness. I'm not sure. Seriously, you think they'd be that small? Oh, I don't know. I mean, that would be another thing I would like to know, is what size balls that chip has on it. You know, for research purposes. You know, because I still don't have a board I know 100% is bad, so I don't really, you know, I don't have a board I happen to rip the CPU off of it for fun. So, I know you have that test board. Okay, so let's check up here by the LCD connector. And this circuit right here is an odd place for a backlight circuit. This is definitely a backlight driver, and it's weird that the backlight circuit is up here and then the backlight is down under the NAND, but I'm assuming it's getting a signal from the LCD circuit, so it has to be close to it. But this is definitely a backlight driver in the backlight circuit. Now that I have my little probe thing, I'm going to be testing voltages on all the rails a little bit more accurately, and I will also either record it or do it on a stream, so you can watch me short chips out, because that would be fun, right? Or short the CPU with the 0.8 volt rail. So, but this isn't that exciting of a stream, but it's information, and information is value. Yeah, on something like that it would be 0.10 mil or something, but I'll have to look later. The CPU's going back on for a while. Yeah, you make sure you let me know when you're going to do that, and I will freaking free my whole entire day up to watch that. You know, I missed some of the switches going back apart last night. I missed the second one. So, but I saw the first one go back together. So, we got some over here on the, I would assume this is the Bluetooth or Wi-Fi. It's open. It's open. 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 Okay. And then we have these. I wonder if these are all going to be open too. Yep. Well, this one should be ground. No, yeah, close enough to ground. Okay, so now we have our SD connector that looks like something I never want to change. You know, I do notice if you do get an SD connector and you pull it off and you rip the pads or something, you know, it's not that much to run a jumper wire. Everything's pretty exposed and open. So I would think that that wouldn't be too bad to do. I don't know how hard it would be to not pull a pad on that. So let me reposition the board here. So we're just going to go through this here. This is what I've been doing. A lot of this I've been doing with the oscilloscope and the unit actually on. So trying to find data signals that could be semi-shorted to ground to cause no power, and the oscilloscope stuff is boring and slow. So that's going to be ground. What is this going to be? Ground. What about this one? Oh, that's, yeah, it's going to be a really low voltage line. Yeah, that's going to be real low voltage. Okay, so we have some test points down here. This is under the CPU shield. That's probably touching the ground. Okay. And I'm not going to be pulling the CPU shield off to test those test points, guys. Sorry. I'm not interested in doing that. I know that's dark. I will fix it over here. There we go. I rebuilt the second one, and one of the screens were smashed from that lot of two. Do it all again. Oh, you could have spent the time to change a digitizer for me. What's up with that? Or do you not have any digitizers? CPU shield comes off super easy. I can do that. Yeah, but I mean, this is a working switch. I don't want to pull the CPU shield off just to get some data point readings that, if you're testing it anyways, like if you're trying to find a fault, you're normally not going to pull the CPU shield just to get a diode reading to see if something's good. So, you don't have any digitizers? I took advantage of that sale yesterday on DigiKey, and I got the digitizers for $7 and the LCDs for $11. So I ordered 5 of each. So because that is a incredibly good price. So now this is the max IC for the CPU. I want to see that one pulled. I bet you that is 3 or 4 by probably 8. Probably 3 or 4 by 8 balls underneath. Yeah, I'll do it on a good board rather than you do. Yeah, well, don't do it on a good one. Do it on that one you ripped the CPU off of. That's like the best test board ever. I was kind of hoping you would send it to me, and then I could just peel off the layers and see what's underneath. So let me flip my ground lead over here. And this is the other max IC that I want to see underneath of, because this one, this is the one that I have a signal going into that could be clipped off, but I don't know, the signal goes in but it doesn't come out, so I can't find it again. So either these filter caps are doing a really good job in filtering all the noise out and I'm not getting noise through, or the signal just ends in this chip and it doesn't, it won't transfer that noise to any of its outputs. So which is odd because normally you can get some noise to transfer. So, and I tried it at different frequencies because I can send in noise that capacitors can't filter out. Like I can figure out what the filter, like what frequencies the capacitors will filter out, and I can put in a frequency that is either a little above that or a little below that, and I can get the noise to go through. And I can also get the noise to filter out a little bit too. Like I can send a carrier and then just have the carrier filtered and the actual signal not filtered. Oh, no test points under the shield. Well, that's good. I don't have to worry about that now then. Alright, we'll come back over here by the battery chip, the other side of the battery chip. Okay. Let's see here. Test all these. Didn't test that one. That's going to be ground. Like a lot of these I know what they are, but I'm testing them anyways for completeness. Like this one and this one are connected, so they're going to read the same, but, you know, I'm touching all the test pads. That's what I'm doing. It's definitely a MOSFET. Alright, any test points? I can test these here. It's probably, no, that's not ground, is it? Oh. Test these here. Open. This one's going to be open too. You know, this set of data lines here, this is a set of data lines from the USB-C port. It has another set of data lines right here on this side. Let's see if I can get this to show it to you. Right here is another set of data lines through a that go directly to the middle of the board, and I'm assuming to the max IC. And then these two right here, I believe, go to the middle of the board, but I am not sure 100% where they are going to, if they're going back through the middle of the board to the P13 chip and their two-way data to actually send out the signal to the HDMI port through the USB-C. I'm not sure. That is the point of the test. So we're going to test this pad. We're going to test this pad here. And not a whole lot of test points. We're going to come up next to, I don't know, is that an audio IC? You can't send that board, by the way. I plan on a CPU swap. Man, you are just, you're either bored or you're hurting for punishment. If I clean that image up a little bit. Yeah. See, if I had to do this under the microscope you actually look through with the eyepieces, I would be done already. My neck would go. It's already not doing fantastic. But this little probe testing unit here is working out very well. And again, these are all the same, but we're going to check them anyways. Now, I don't plan on doing every component on the board. That would be insane, but I do plan on testing some lines, looking for the data lines, because other than power rails going, data lines will shut down a unit pretty quick. Hey Neil, how's it going? I like the challenge. I know you like the challenge, Phil. Yeah, Phil does love the punishment. Sometimes I like to egg him on to see what he will actually do. So far, everything. I remember he did a video on reballing a chip by hand. And I was like, no way, you should do that live. Nobody's ever done that. Now he's done, what, like 3 live? That's insane. I'm not taking credit for him doing that live. I'm just saying I brought it up, and now that's all he likes to do. Yeah, that's why, yep. You know me, I'm scared of everything. I'm not going to try anything unless I research it and test it and make sure it works and put a label on it. Okay, we are going to take a little break from that, and we are going to come up here and we are going to take a minute to hear from our sponsor, Dynamo, one of the best label makers in the world. And we are going to make Phil another label for being so helpful, because he was super helpful last time and he didn't get a label. He does have a label right here. This is his first label for saying mean things. So that's his first label. We're not going to read it. We'll show it to you. So now we are going to make Phil another label. And we are going to say the coder with the 3. Loves playing with balls. Oh, no, can't misspell it. Balls. Okay, let's get you your other label here, Phil. So there you go. Now you have 2 official labels. You got your label talking about how you love playing with balls on all your CPU reballs. So we'll put that up there with your other label. So you got 2 more labels. You can earn yourself another label here later if you're a big boy. Okay. So that, and Dynamo is not a sponsor of this video. I just buy their labels in bulk and they're fantastic. So I just wanted to take a little break there. So this is the testing the test points on a board. That was been on point. Yeah, I figured you'd get a kick out of that. Okay, it is 6:30, and I have to get my son up for school. So thank you all for stopping by. I greatly appreciate it. I will finish this up and do some actual voltage rail testing too on the next one. On Saturday, I will be streaming my first ever change of the P13 chip around the same time, if not a little bit earlier. So I'm going to be changing P13 on 2 separate switches. So, and then we're going to try to get the switch 1 or switch number 3 to actually work and charge on both sides. So, oh, you're going to go get the cups? That's cool. Yeah, so I'm going to finish this up on another stream probably during the week, and then do the voltage rails also. That's going to be a little bit trickier, but I'm going to get that done. And Saturday, check out the stream on Saturday around the same time. I will be working on the switch, changing P13, and getting that done. Thank you all for so much for watching. I hope you guys have a great day.